All right, we're going to start off with a little lesson and then we'll get into some problems. So right now, I want to talk about the flip-flop. The flip-flop is, all flip-flops are 1 bit. 1 bit means they have the binary high or low, 0 or 1. 0 is low voltage, 1 is high voltage. So that is 1 flip-flop, it's 1 bit. Now, you could take that flip-flop and chain them together to have multiple flip-flops, like so. This is 2 flip-flops. How many bits would that be? 2 flip-flops equals 2 bits. Now you could do it another time. Chain another flip-flop and add 2 more states. So you have 3 flip-flops equals 2 to the 3rd power. How do you do the 3rd power? 2 raised to the 3rd. Two times 2 is 4, times 2 is 8. 8 states. So you have 8 states. And if you wanted to write this in Verilog, when you define the code, or when you define your ports, 3 bits, which is 3 flip-flops, 2:0. That's the width of your wire, of your signal. So 3 bits is written like that. Now, if you write this in binary, this helps. 0 is in binary. One, 2 is written 2 0 1 0. One 10. Nine. All right. See, this is 2 bits, 2 numbers, 3 bits, and 4 bits. So now you know a little bit about what we're doing. Now let's do this problem. We have a modular counter that counts up and down. It has an enable and it has a terminal pulse. So it's going to count from 0 to 7. So 7 in binary is, what did we say it was? 1 1 1, 3 bits. 3 bits is written 2:0. So let's define our ports. Now build the here's our wires that we're going to input. Remember, everything has to go in order of operations, just like in math. So first is reset, then it's load, and then it's third final, it comes operations like counting. So let's do that. Define that like so. So here's your load. What are you loading? Let's put in the data. What is it? 3-bit data. Next order of operations, load. It is enable. Then you've got your then we do our what we're going to do is count. So that needs a direction input. One flip-flop to do that. And I'll put register. This would be three bits. Oh, excuse me, 2 bits. That's it. Now let's do this order of operations. Starting with reset. Oh, that's what I forgot to do. So actually we have combinational logic here. That'll come first. We'll do our steps. Combinational logic, which will be the terminal pulse. Forgot to put that in. Let's build that first. The terminal pulse is when the count reaches 7 and enables 1. So how do I write this? So when Q is 3, three bits 111. And enable. Say that. What am I doing? So the terminal pulse is assigned when the output is 7 and enable is high. Now we're going to do our sequential. Let's do our reset. Synchronous, so it's at the positive edge of the clock, which is high. Clear all the registers to 0. Clear everything to 0, or a known value. In this case, we're going to do 0. Now let's do the load. Load the data. When it's hot, when the signal is high. Now it's a counter, so you need the to the wrap and the rollover. When the number goes, so we're going to count from 0 to 9. So when it gets to 9, it rolls over and wraps to 0. Roll over to 9, wrap at 0. ¿Hay capito? Good. Rollover. Let's write the rollover 9. Rollover at 9. Wrap at wrap at 0. Get away from me. Rollover wrap. Now we need to count. Counting from 0 to 9. You take your state. On the right hand, so what happens with this here is these cues are your outputs. It's your state. It's this here. So the data is coming in and then the data is leaving the flip-flop. That's what you're seeing right here when I'm building this. This builds a circuit like this. There's your clock. There's your clock. There's your data. These are A is, well, it's a signal, but, and there's your enable, there's your reset. Just the same. Speaking of, I forgot to do the enable. Okay. Now we've got our enable, load, enable. All right, let's see what else I've got. The reset, enable, load, direction. So it's going to count up and down. So this is 7. What is 7 binary through? Okay. Okay, then that means I'm going to do this, flip this around. This is counting from 0 to 7. Now I need to do this same thing, but count down. So this counts up. Now I need to do one that counts down. But it won't be high. This is high signal, high voltage. This is going to be counting down. Derp. So just flipped it around. See, it's just a mirror image. Now, okay, that looks see if we got all our stuff. Nope, I don't have direction down here. How do I put this, define this direction? I had enable doing it. I gotta put this direction in this. Where do I add direction? Where do I do it? I want to say it goes. Like direction is high, counts up. If direction's high, it counts up. If direction's high, that seems right. Can I have another begin? Yeah, another begin. And that's That might be right. Something might be nested if statement by let's plug her in. See what errors we get. Let's see what errors we got here. Let's try. So if directions begin, I think I got an idea. All right. This has to be separate. If enable is high, right? Maybe it's as simple as no, I don't think that's right. If enable's high, let me see here. Let's just plug this in real quick. Let's see what we got here. Actually, it looks pretty good. It looks pretty good what I had. Just take that back. Let's see here. I think this, yep, I think that's where it needs to go. The circus. I think I'm. Still something yelling at me over here. 30. 30 and 30. If begin. I always mess these up. End. It's just that. That's not right, but let's see what it does. Sorry for the inconvenience. If direction. Okay, let's see if this is it. Come here. Something. If direction, if enable, begin. 3 ounce. If enable begin, if direction begin. Wait, no, that's right. Yeah, that's right. What's wrong with it? Else if enables begin, else if directions begin. Does this need an if statement in front of it? Yep, that's it. Derp. Simple as that. See how that has an if statement? That needs an if statement. Now this should be else if. It's gotta be, I need a statement there. Nope, just gotta be else. There we go. Okay. That looks right. Now we're good. I'm done. Deuces.